Okay, so this chapter we are going to start working on the data transmission. This is our first chapter on telecom and WAN security. This is the textbook used, business data communication. This is chapter 4 in the book. Since we are talking about telecommunication, it is worth, or it's very important to understand the meaning of electromagnetic signals, because it is very important in our life. This is how the signals are transmitted in most of the telecommunication environments. Some of the characteristics of electromagnetic energy or electromagnet energy we will study in this course. First thing, we need to know that electromagnet energy travels in waves. It's not linear. It will travel on waves. Like, you know, when you drop a stone in a lake of water, what will happen? Waves. When you talk, everyone will hear from all the sides, huh? Because it is traveling in waves. When we walk linear, huh? Nobody waves. But electromagnetic signal, I'm not asking a question. I'm just giving it. Okay? So electromagnetic signal travels in waves. So it will radiate outward from its source. I have transmitter, everything will be radiating or traveling in waves from the center. In a computer network, the source is generically called a transmitter or sender. In computer network, we call it sender. In telecom, we call it transmitter. The electromagnetic energy that is created by the transmitter is carried over transmission media in the form of electromagnetic waves or signals. Why we call it electromagnet? Because it is involving the electron and magnetic. And you can generate, we know that we learned that we can generate electricity from magnet, okay, and magnet by electricity. I think you studied this in physics. Yes. Fundamental characteristics. When expressed mathematically, it's a function of time. Usually we express electromagnetic signal in the function of time or frequency. Like if you want to talk about the speed of a car, you express in what? Kilometers per hour. Okay, so electromagnetic wave, when I want to express or describe it, it's a function of time or a function of frequency.
This is the hertz, yes? Hertz.
It is the presence of multiple frequencies that enable us to distinguish between them. The frequency view of a signal is most important for understanding data transmission. So we have to understand frequency, all these terminologies in order to understand transmission. First, let us talk about the analog and digital waveforms. The one on top is analog or digital. This is an analog. Why? Because it is changing. It's not constant for certain time interval, then it changed to another. It's not like pulses. No, it is changing. At each second or millisecond, it has a value, and it's moving. That's why it is analog. The second wave is digital. As you can see, the digital is discrete. We call this discrete values. 5, -5, 1, 0. Yeah. It's discrete values. Positive, yani this value or this value, this value or this value. Like binary, it can represent binary or digital. Okay. What is the amplitude? Amplitude is here. The amplitude is the value, the highest value of the signal. These are examples of periodic signals. Why we call it periodic? Who can tell us? It's repeating itself, yeah, periodic. Very good, very good. Okay, so it will do one cycle, then it will do another cycle, another cycle. So it's periodic, it's repeating itself. All right. So here, for the first signal, it is repeating itself. But if you look here, period or the time it takes to complete one complete cycle, we call it period. So from here to here is one period, and this is equal to t, and t is equal by definition to 1 over frequency. In English, the period is the time needed to complete one cycle. We call it cycle. Okay? Period is the time needed to complete one cycle. Frequency is 1 over period. So here, if we look here, here there is no number, so we cannot find it. Let's look. We have some examples here, alhamdulillah. But first, let us know these terminologies. Peak amplitude, what is it? Please, you have to know these definitions. Maximum height of the wave, above or below given reference point. It represents the strength of the signal over time. Typically measures in volts. The frequency, we already said that frequency is 1 over period. And in other words, it is the number of signals or complete cycles per second. Frequency, number of times the signal makes a complete cycle within a given time frame. In other words, number of complete signals or cycles in 1 second is frequency. And it is expressed in cycles per second. As our colleague here said, it is hertz. The unit for frequency is hertz. Period is the time interval for one cycle. So this is in seconds, milliseconds. Phase, a measure of the position of the waveform relative to a given moment of time within a period of a signal. Yani the phase or the angle of the signal, when it is starting. Is it starting with lag? Is it lagging? There is an angle. We call this phase. We'll show you some examples. Any questions? Okay, let us see this example here. Is it clear? Yes. Okay. For the first signal, look at the values. What is the amplitude?
1. The height.
1.
1.
1. We call it 1. The amplitude is the absolute value. Okay. What is the period?
0.1.
What is the time needed to complete one cycle?
0.1. Yeah, 1 second. 0.1.
1. Okay, so what is the frequency? 1 over period or 1 over time? 1. 1 over 1, 1. Here. Because from 0, look here. Going up, going down, going up, then it will start again.
Doesn't stop there?
No. It will continue. This is just a part of it. Okay? What about this one?
0.5.
What is the amplitude?
0.5.
0.5, yes. And what is the time or period? 1. What is the frequency? 1 over 1, 1. Very good, very good. What about here? Here we have, what is the amplitude? 1. Now look, what is the period here? What is the time needed for 1 second? Very good. Half second or 0.5 of a second. So what is the frequency?
0.5 or 1? 0.5 over 1. That's 1 over 0.
1 over 1 over t, 1 over 0.5. So what's the answer? 2. 1 over half. 2. And how many cycles I have for 1 second? If you look here, from here to here is 1 second, sir. How many times it's repeated? 2. So by looking at it, I can understand. Does not matter. I start from 0 actually. 0. Yeah. 1 up, 1 down. Here, when you come back to 0, then it is 1. Up, down, coming back to 0. Then I will start another repetition. What about here? Phase is what? Because we are starting from 0, right? There is no delay. So here the phase is 0. The phase here is? The phase here is? What about the phase here? Is it 0? Yeah. In angle, we call it phi. And it's equal, phi is equal to pi over 4. Pi over 4. This is how they write it. In degrees, angle. It's an angle. Remember your angles, physics also, math also? Yeah, the angles, 90 degrees, 45. Okay. What about here? What is the amplitude?
1.
Very good. What is the frequency? What is the period?
1.
Yeah. And the frequency is 1 over p, which is 1. Very good. Now we talk about some other terminologies. First chapter, a lot of terminologies because it's a new topic. And you are doing great. We have the spectrum. What is the spectrum? Spectrum is the range of frequencies that a signal contains. So it's everything. All the frequencies is called the spectrum. The absolute bandwidth is the width of the spectrum. So my spectrum is very big. The width of this spectrum, we call it absolute bandwidth. Not bandwidth, absolute bandwidth, the whole bandwidth. The effective bandwidth is a relatively narrow band of frequency where most of the signal energy is found. The strongest part of the spectrum of the bandwidth, we call it effective. Okay? Like I'll give you an example. You know, when you have a torch light, you come to a dark room and then you turn on the torch, the light will be, the spectrum will be big. And the absolute bandwidth will be like maybe 5 meters. But the effective bandwidth will be maybe in the middle, 2 meters, 1.5 meters. Okay? Trust me, you don't have to go tonight and buy torch and trust my. Okay. And then we have, we need to know that the greater the bandwidth, the higher the information carrying capacity of the signal. For me, I'd like my signal to have high bandwidth because this will give me more capacity. Okay? But also it will cost. So this is an example of analog signal, a human voice. In this graph, a typical analog signal, the variation in amplitude and frequency convey the gradations of loudness and pitch in speech or music. Okay? Similar signals are used to transmit television pictures, but at much higher frequencies. Okay? So this is the human voice. Human voice, by nature, it is generating this analog signal. It's going up and down, but variable. It's analog. No one is talking digital, right? Nobody talks. Can anyone talk digital? Do you know anyone who can talk digital? Nobody. A human being, right? The voice band, also they measured it, the scientists. They found out that the human voice creates waves of many frequencies. By natural, sounding speech can be limited to a frequency range or band for a human from 300 to 3,400. 300 to 3,400 and 3.4K maximum frequency for a human voice. You cannot go above this. Okay. So telephone equipment allows voice a bandwidth of 4,000 hertz. That's why the telephone company, they program the telephone equipment, or the manufacturer, to handle 4,000. They put some extra, and I will tell you why. So here we have from 0 to 300, from 300 to 3,400. This is the voice bandwidth, and this is the channel given to me by the telephone system, 4K. Okay. Why we get 4? Why we have this extra? So that it does not interfere with the next signal or with other signal. That's the only, that's one of the reasons. So this will prevent interference from other signals. We call this guard band. Guard band.
So they limited it to 3,400. The other issues similar to this kind of.
Yes, in the previous telephony systems. Now everything is digital. Guard band. We have channel, and that part is called guard band. Video signals. Video needs more frequency. We said that voice from 300 to 3,400. Video needs more because there are many things you need to represent. Okay. The television camera, it will produce video signal. To transmit analog video information, the necessary rate, a bandwidth is about 4 megahertz is needed. 4 mega we need for analog video signal. However, video signaling over cable TV or via broadcast involves the use of extra bandwidth or, again, guard bands so that they don't interfere. This is very important in telecommunication. You need to put some guard band because you need to, you don't want interference. Okay? So with these guard bands, the standard bandwidth of a color video signal is 6 megahertz. From 4 mega, we are 6 megahertz per channel. With the guard band. Yeah. The original 4, 2 plus 2, 6 megahertz. Yes? Here we have happy man here. He is sending data. He is typing. And the computer will understand, will convert everything into binary. We know that. So user input at a PC is user's input. Whatever he input here is converted into a stream of binary digits, yani digital or binary, zeros and one. In this graph of a typical digital signal, here we have the one is represented by what? How many volts?
5.
1.
5.
1 minus 5. By the way, it depends on your, sometimes the 1 is minus, the 0 is positive.
Here, the 0 is positive.
Yeah. Here is the 0 is positive 5.
So
Okay.
it can go straight down, straight up.
Yeah.
Like that.
Yeah. Jump, it will jump. Okay. If you look here, the signal for each bit has a duration of 0.02 millisecond. You see the changes? Intervals, we call them intervals. So each bit will stay for 0.02 millisecond. Then either it will repeat itself or it will change to another value. Okay. Oh, very important topic. Transmission impairments. Impairments meaning noise. And we have very important information to notice about transmission impairments. First factor is noise. Noise is collective term for various transmission impairments. We call them noise. Can cause a bit errors for digital signals. And it is the electromagnetic or electrical energy that degrades signal quality. Okay. We don't want, this is the first enemy for telecommunication or for transmission, noise. Because it will reduce the quality. If the noise is high, the quality of your signal is low, or of your transmission. So it introduces various random modifications that degrade signal quality for analog signals. So this noise can cause my signal to go maybe up higher than it's supposed to be, or maybe lower. So the receiver will not understand what's coming there, what he's receiving, because of the noise. Present in all types of data transmission systems. Okay. So we have divided it into guided media noise or impairments. Guided media meaning like what? Guided media, yani cabling. Okay, copper. Okay, unshielded twisted pair, fiber optic. So the most sources of signal quality impairments are attenuation and attenuation distortion. Attenuation by nature. Signal, when it's traveling, it will lose some of its energy. So after some time, it will be dead. Yes, subhanAllah, it's great. This is nature. This is how God created the universe. Okay.
We can put a device that can keep.
We have some devices, repeaters, but for limited also. We talk about it. Very good. Okay. We have also delay, distortion, and we have noise. We'll explain each one now. Attenuation, when electromagnetic signal is transmitted along any medium, it gradually becomes weaker at greater distances. When you travel further, it will become weaker. You have to consider 3 considerations. A received signal must have sufficient in strength so that the receiver can understand. Okay, I send a signal, but when it's received by the receiver, he received, or the receiver received some signal, but very weak. You cannot understand what is this. Is this zeros, ones? So it should have enough power when it arrives. The signal must maintain a level sufficiency higher than the noise to be received without error, of course. Attenuation is greater at higher frequencies, and this causes distortion, of course. When you have higher frequency, you will lose power faster. Why?
Consumes more energy.
Yeah, because it's going up and down, like jumping, you know, up and up and up. Up. So it will lose energy fast.
So it needs more power.
Yeah. Yes. So here, to overcome this problem, okay, we have amplifier. If I am using analog signal, I can use the amplifier. The amplifier will amplify everything, the signal and the noise. If I am using digital signal, I can use a repeater. A repeater is good. Why? Because it will remove the noise and then regenerate the original signal. All right? Different attenuation problem happens only in analog signals. Solution attenuation equalizer. The solution is attenuation equalizer.
What's the second picture, Doctor?
Here we have a repeater.
The beside it. On the left.
Here?
Yeah, this one.
Yeah, this is the original signal.
Then it goes
With some noise, it's becoming like this. I enter it input into the repeater. It will remove the noise, regenerate the signal. Very good. Okay. Amplifier. It will amplify the signal. Problem with the amplifier or the
manually.
the characteristic of amplifier, it will amplify everything. It cannot distinguish between the noise and everything is amplified. It will amplify, so it will travel further. Amplifier for analog, repeater for digital transmission. Again, for guided media, cables and fiber, we have another impairment, which is called delay distortion. Delay distortion meaning that various components of a signal arrives at receiver at different times. It happens in transmission cables. Does not occur when signals are transmitted through the air by means of antennas. It's caused by the fact that velocity of propagation of a signal through cable is different for different frequencies. SubhanAllah. We are sending the signal in the cable, and the signal, parts of the signal is traveling faster than the other parts, depending on the frequency. So this also causes something called delay distortion.
And how can we avoid this?
There are different techniques. You can correct the signal, or you can request to resend the signal. Okay? We will talk about how to deal with this, with errors. Now we are talking about what are the types of errors. Okay? Yeah.
So in terms of
Yeah, we already mentioned this. So let's jump to the second one. Noise. Noise is the major limiting factor in communication system performance. We have 4 categories, and I think you know them all. Thermal. Temperature, high temperature is also an enemy for telecom.
High temperature?
Yeah.
Like csf temperature.
Thermal, no, we're talking about very high temperatures. So thermal noise, often referred to as white noise, is dependent on the medium temperature. That's why we keep the server rooms, data center in controlled environment. Correct?
On the temperature for the machines.
Machines, yeah.
Oh, okay.
Machine, transmission, cables. Okay, you don't keep the machine in cool temperature and then you put your cable on fire. Correct? What will happen? You will torture the data. Intermodulation noise, when signals of different frequencies share the same transmission medium. This is intermodulation. So signal is jumping from this wire to this wire. Just like that. It decided to jump from the wire to the other wire. Crosstalk, we'll talk about crosstalk. And then we have impulse noise. This is non-continuous, consisting of irregular pulse or noise spike. Sometimes if there is a lightning, there's a lightning. Now telecom companies, I think they fix these things. But in the old days, if there is lightning, you will see telephone, the TV signal is gone.
Yeah. Even rain.
Yeah, rain. When it's raining, there is lightning somewhere. So when it rains, there is lightning somewhere.
But I think also like heavy rain affects the signal.
Also, yeah, humidity, water. We'll talk about this. All right.
Nowadays we don't find these issues because
they improved. They improved their techniques.
Before we use satellite, now we all use cable.
Yeah. So this is called impulse noise. This is the effect of noise on digital signal. You see here, this is my signal. Very nice and neat. Then noise is coming. Boop, 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 boop. What will happen to the signal? Look how it horrible. Look. Can you tell this is 1 or 0? Almost. But if the noise is heavy, you cannot tell whether it's 0 or the 0 can become 1. 1 can become 0. So the signaling, this is the timer or the clock. So this is the data received. And this is the original data. This is my original data, 10100. Here I have some error. The original data was 0, but because of noise it became 1. So this is error bit. Okay. Here I have another error. The original data was 0, but the data received is 1. For unguided media, Mr. who was asking for unguided for wireless? Yeah. We have these factors. We have free space loss, signals displaced with distance. Same like attenuation. But because it is wireless, we have another name for it. We like to name everything. So this one is called so that we can ask you in the exam. Free space loss. Signals disperse with distance. Disperse and weakens. We have the atmospheric absorption, okay? Because of vapor, H2O. H2O is also problematic for signal. That's why people who go for the sea, fishermen, anybody here go for fishing? Yeah. What happens with the signal? Yeah, you will have a problem. That's why you have to inform Coast Guard before you go. And then they give you VHF radio or marine radio signal. Yeah, they will give you some No, VHF. REAP is pager. VHF, right? Marine radio.
It's like
Radio.
solid wood.
Yeah, radio. Yeah. VHF. Even the ships, you know, the ships, these oil tankers traveling in the ocean. You think the captain will be using mobile to call? He has to rely on VHF radios, satellite communication, even for their internet. Yeah, it will be, of course, different. Now VHF, you can get very good quality. All right, so we have also multipath. What is multipath? Multipath is, no, this is my router or access point. When it's transmitting, it will transmit on all directions. But what will happen? It will go to the wall also. It will come back. So I am getting a duplicate of the signal. I receive it now, but then after very short time, I receive the same data. So we have to account for this. Even the human ear. Now when you talk, say A. I received it here, but also it will hit the wall and come back to me. صح? It will hit the ceiling and come back to me. It will hit your colleague and come back to here. Yeah, but what happened? Very good question. God created, subhanallah, a human ear that if the difference is very, very, very short, your brain will ignore. Otherwise, what will happen to us? It will become crazy because you will hear something 10 times. SubhanAllah, human brain will not distinguish this. It will consider it one time. Like when this light here, actually this light is going on and off how many times? How many times? Very good. 50 times. Put your hands together, please. 50 times, mashallah. Because the frequency is 50 hertz. Yeah. You can explain to them after the okay. Then we have the refraction. Refraction is change in signal speed due to atmospheric condition. The signal is passing from one material, let's say from the air to water. What will happen to the speed? It will change. It will change speed.
It goes through water?
Yeah.
The signal?
Yeah. It will change its speed.
Should not reflect?
No, I'm not talking about reflecting. I'm saying this, you have water at the sea. If you put light to the sea and to the beach, what will happen? The light will go straight, it will read that, we call this refraction, not reflection. There is reflection, but there is also refraction. Refraction that it's not going straight, it is refracted in any way.
Two directions.
Yeah, we have reflection coming back. We have reflection.
And this one same for the signal?
Yeah, it is a noise. It's considered a noise. Thermal noise. It is white noise. Arises from thermal activity of the devices and media in the communication system. We call this thermal noise again. Okay. So even for Wi-Fi, thermal is an issue. You have to consider.
The thermal noise doesn't affect both the signal and the device.
Of course, hardware and signal. Yeah, we have to consider it. We have to consider it. We have to accommodate. We have to control.
Because I have heard of devices that some people use to help the other devices. So, for example,
That's to block, to jam,
Yeah.
Yeah, that's different. They will generate signal as noise to jam other Yes. I think police maybe sometimes they use this. In some areas when there is big event, they jam communication so that people they cannot make calls or at that time. Okay. And also in case of emergencies, what will happen? This is something off the record. If there is, like, let's say, God forbids, an emergency, you know what will happen? Or let's say there is a party, and I have, or people, 100,000 people watching a match. If they all decide to use the mobile, not all of them will be able to use the mobile because there is no channels enough for 100,000 people at same location, unless the telecom company, they provided extra equipment at that location. Extra equipment and bandwidth, because you need equipment to handle the channels, the calls.
That's why the internet is slow and the Expo and the Global Village. Right?
It depends. It depends. Okay. Actually, I tried internet there. It was perfect. It was very good. All right. So channel capacity, it is the rate at which data can be transmitted over a given communication path or channel under given conditions. This is the definition for channel capacity. There are 4 factors for your channel capacity: the data rate, bandwidth, noise, and error rate. These are all factors important for your channel capacity. If I have high error rate, this will reduce my channel capacity. Okay, like you have a road, but you have a road that has 5 lanes, but 2 lanes are bumpy. There is bumps and noises, and so actually, what's the capacity? Instead of 5, it's 3 only. Okay. Thank you very much.